You've seen those seamless 4K corporate broadcasts in enterprise lobbies, or like those endless live data feeds on trading floors. Today, we're looking at the actual iron that handles all that heavy lifting without, melting down the network. Welcome to today's deep dive, where we are decoding a product spec sheet for the Vitec, formerly Exterity AVSTR-C1103 3-slot chassis.
Yeah, a spec sheet might seem incredibly dry at first glance, but it's really the architectural blueprint for how an enterprise moves massive amounts of high-definition video, and it does this without completely suffocating their standard Wi-Fi and data traffic.
Right, and here's where it gets really interesting. This one piece of hardware reveals the hidden infrastructure of the modern workplace.
Oh, absolutely.
Because the C1103 sits in a 1U rack, which is basically a standard pizza box-sized server slot, and streams live TV, radio, and internal video over an organization's existing network.
Yeah.
But how does it manage that without just choking the bandwidth?
Well, that really comes down to how it handles the data at the source. The chassis itself is essentially a highly customized power and networking shell. You populate it with up to 3 distinct blades.
Blades, right? Like cartridges.
Exactly like cartridges. So, for example, a TV gateway blade literally takes a raw coax cable signal from a satellite and chops it into efficient dating packets. That way, standard network switches can route it easily.
Or you could use an encoder blade instead, which takes an uncompressed camera feed and compresses it on the fly. So instead of one massive monolithic server, you have this 150-watt base unit mixing and matching these targeted blades.
Yeah, which gives you the flexibility of their massive 10-slot enterprise units, the C1110, but in a footprint small enough for a local branch office. Or you could scale all the way down to their compact 1-slot C1110 if you needed to.
Wait, so if you're mixing and matching these blades in a live environment like, say, a hospital,
Yeah.
where the educational feed absolutely cannot drop, how do you fix a broken encoder? Because pulling a module out of a live server sounds like a great way to fry the board and take down the entire building's broadcast.
You'd think so, definitely. But the chassis is fully hot swap enabled.
Oh, really?
Yeah, you literally just slide the malfunctioning blade out and slide a new one in. And you do this while the 150-watt power supply is fully active. The other 2 slots don't even blink.
Okay, let's unpack this. Because the specs claim this zero downtime magic is thanks to a passive backplane. And in tech, passive usually implies something outdated or inactive, right? Why is a passive backplane the secret weapon for enterprise reliability here?
What's fascinating here is that active hardware means computing chips, and chips generate heat, experience logic errors, and eventually fail.
Right, of course.
So a passive backplane removes all that complex circuitry from the main communication board connecting the slots. Think of it like a heavy-duty extension cord rather than a smart hub.
Oh, I see. A smart hub has a brain, so it can crash. An extension cord is just copper wire. It just passes the power and data through. So if a blade completely shorts out, the backplane doesn't care. It just keeps feeding the other 2 slots.
Precisely. You isolate the complexity to the individual replaceable blades.
But wait, if the backplane is just a dumb physical connector routing power, how do you actually know if a specific blade is failing before the CEO's company-wide broadcast goes completely dark?
Well, that's where the physical design steps up. On the front panel, each slot has its own independent Ethernet port, plus an RS-232 port.
RS-232, that's a direct serial connection, right? Like for when the main network is completely down and you need to physically plug a laptop in to talk directly to the machine.
Yes, exactly. And right next to those ports are instant visual diagnostics. You have your standard Ethernet activity lights, but also a literal heartbeat LED for every single blade.
A physical heartbeat monitor for the server, that's wild.
It is. And if we connect this to the bigger picture, imagine you are an IT tech standing in a free-build deafening server room at 3 a.m. Ugh, the worst.
Right, you do not have time to log into a remote dashboard to figure out which module is dead. So seeing that pulsing physical heartbeat indicator immediately bridges the gap between a complex digital failure and, immediate physical troubleshooting.
It really highlights how much thoughtful engineering goes into the zero downtime communication we all just sort of take for granted. Like, you're building a system that actively anticipates its own components failing and ensures it can be fixed by a tired human at 3 a.m.
Yeah, it's the very definition of robust infrastructure. You don't notice it until it's gone, which is exactly why it's designed to never go away.
Exactly. And speaking of design, there's one tiny detail in this spec sheet that left me thinking.
Oh yeah, what's that?
The C1103 ships with blank blade ends. which are literal metal shields designed to protect the empty, unused slots before the chassis reaches full capacity.
Right, to keep dust out and airflow consistent. Yeah, but it makes you wonder, as you walk through those airports or enterprise lobbies, taking the infrastructure for granted, how much of the technology running our world right now is secretly housing protected, empty space, just waiting to be expanded? It is definitely something to mull over for your next commute.